In this video, I'm going to discuss about what is binomial distribution. Binomial distribution is nothing but it's a sequence of n Bernoulli trials. So we have learnt about the Bernoulli trials in the last video. So when we have an n sequence of independent Bernoulli trials, we call that as binomial distribution. In other words, we can also say that Bernoulli distribution is a special case of binomial distribution where we have only a single Bernoulli trial, right? So there are two conditions to be followed. First thing is that the trial has to be independent. So that's the first condition. This condition has to be met. And the second condition which has to be met is that the distribution has to be identical. So that's another important assumption. That means the probability of success or probability of an event happening. If you remember in the last video, we talked about the different events, the two outcomes or the probability of the outcome of interest has to be same in all the trials. So that's another assumption. Or in short, we actually call it as identically and independently distribution, or we call it as IID, identical and independent distribution. So there are two parameters in these probability distributions. One is the number of trials denoted as n, and the other one is the probability of success, which is uniform across all the trials, which is p. So given n and p, we can actually have the probability density function. So the density function or the PDF is given by this. So the probability that the random variable x, so what is x in this case? The random variable x takes the value of number of success in this case, or number of the events happening, or the number of outcome of interest occurring in the n trials. That means, for example, if you want to know how many number of heads are happening, right? So getting a head is an event here. So how many heads we are getting when we have like n number of trials? So that's one thing. So that one thing is captured by the random variable x. So that is given by p, which is the probability of getting the event, which is the unconditional probability, and the number of trials happening. The number of trials is n, and then we have this probability density function, which gives us the number of chances of success if you have n trials. Now a typical probability density function looks like this. When we have n is equal to 50 and p is equal to 0.5, if you draw it, you will get a PDF curve like this. And if you change it a bit, we increase the number of trials and increase the probability value, it will be a little skewed, and if you decrease it, it will be skewed towards left. So that's how we that's how the probability density function look like, and we'll also see that using SAS and R in the next couple of videos.